Hey, Snackers, this is Kareem Iskander.
Hey everyone, Matt DiNapoli here.
Welcome to episode 204 of Stack Minute.
This week we wanted to change it up a little bit. We've been talking about AI and MCP servers almost in kind of a context or in a conceptual manner, not contextual, in conceptual manner. And we actually wanted to bring, well, we wanted to bring some context to a real life use case to leveraging these kinds of tools in infrastructure management. And so we brought our friend Matt Shooshtari here. Matt, introduce yourself real quick, and then we'll jump right into it.
Hi, I'm Matt Shooshtari. I'm a technical leader with DevNet Engineering. I have a background in DevOps, cloud, and I've worked with a lot of startups, brought a lot of good ideas before Cisco, and I'm really excited to bring some of those ideas into improving how we run our cloud systems, how we can automate things. And so I've done quite a bit of work with MCP tools, and I'm happy to share that today.
Yeah, the reason I wanted to have you on was we were talking, it's been a few months actually, it was probably in June or so, about some of the work you were doing with some of the SRE activities that you guys were working on, and how you were leveraging AI tools. And at the time, I think it was kind of moving from experimental into practitioner type level activities. And, I wanted to see how things were progressing, some of the challenges you ran into, and kind of specifically what we're looking at today, to kind of give our snackers an idea of how they can take advantage of these tools in their everyday lives and make it kind of a realistic thing rather than a conceptual thing.
But before we get started, Matt, wanted to ask you, is that a bunch of oscilloscopes behind you?
It is, yeah. I do a lot of work, not just automating things in the cloud, but I have hardware projects that I like to automate, and I like to also fix vintage audio equipment. So, it's really kind of this holistic part of exploration and figuring out how things work and trying to make them better.
True nerd at heart.
We'll have to have Matt come back for another session, because he actually has been leveraging AI tools to repair vacuum tubes, if I have that right.
Yeah, it's something new and challenging, and the people that know about it, they're retired or passed on, and so AI is filling the gap as far as training and instruction in those ancient ways, I guess you could say.
And okay, sometimes knowing the ancient ways is really good. But I digress.
Me too. Sorry.
Yeah.
It was my fault.
Let's get to the topic of the day, which is, Matt, I'll let you kind of introduce it, and then Kareem and I will ask some questions as we go along.
Yeah, sure thing. So we had some challenges, coming up with how do we secure clusters better? How can we be more proactive? And how can we get these different cluster updates done quickly? And before, we would have to go and look at the cluster, evaluate it for readiness. We didn't really have the ability to do a rolling update, so it was a lot of risk involved. And then, when we built that, it was still a very manual process. A lot of, checking things. Was it the right hardened image? Was the cluster going to be successful? And how did we know if our steps work? It just,
and these are, Matt, these are EKS clusters?
These are EKS clusters, correct.
And they're running on cloud infrastructure or on on-premises infrastructure?
They're running on cloud infrastructure. So this is AWS EKS. And AWS offers a lot of these upgrade paths to upgrade the backplane, upgrade node groups with launch templates. But it's still, what you put in the launch template, what you set things for, how you choose the hardened Cisco image, that's all variable. Cisco releases new hardened images on a regular basis. And so it's hard to know, what's the one I should choose? And I've got to find it and put it in there. We just wanted to make this faster so that we could go through and say, is there a cluster? Is it ready to upgrade? Can we upgrade it? And can we do it in a way that is safe and stable and those sorts of things? So the first process was, let's do something deterministic. This is kind of old school DevOps, SRE stuff, write a script, write a process, but, it's still very I have to find the AMI and I have to put it in there, and I have to do this and I have to put it in there and load the script and run it. Well, why not have MCP tools where your agent can go through and find the right AMI and then bring it into the next step of the process for you? So this really, improved the way that we operate things So that was a challenge, and then it led us to MCP as a solution and agentic process.
So is MCP and the server is built in-house, or is this something that you've leveraged from AWS?
This is built in-house, so this is Python with the Boto 3 library. It started out as a command line, the deterministic process, but because it had a very, it had a a CLI to interact with it, and it had a service layer. It's not very hard to build an MCP server layer on top of that with the different tools, and that way your agent can look at it and say, okay, if you want to upgrade, I'm going to run this path with these arguments. If you want to check the pre-flight, I'll run this path with these arguments. So it does a really good job of routing there and getting the same thing done in a conversational way instead of a copy paste data way. So another thing that was really cool that I found is that when you are conversating with this, not only can it use this tool, but it could use your AWS CLI that it happens to have a session and grab more data, and it all builds it together. So using Cursor, using this agentic way is just it's night and day easier. I could just have a conversation about doing my job.
But that's an interesting thought about how being able to see into what the agent itself already has access to. That part is interesting, because I would have thought you might have to preset that up, but it sounds like, I guess, if you're tapping into an existing AWS agent, I guess the logical conclusion is that it already has access to that CLI. You had mentioned finding the AMI and launching the update, and the pre-flight checks and things like that. What are some of the other challenges you hit before we get into the solution?
Some of the other challenges were, the monitoring and the knowing things were ready to go. Before, we would have to go and open several of the windows within AWS EKS, look at the workloads, look at the pods, look at the node health, things to make sure, like, did it really succeed before we start doing the next node group? So this was risk mitigation, very manual process. Of course, the APIs can do this very quickly. It can say, did the node group come up? Is it ready? If I check, workloads on their pods, deployments, etc., are they starting? Are we running into disk pressure issues or memory pressure issues? The things that you might have when you start workloads on a new cluster. So this starts checking at that deeper level and says, yes, I have a high confidence that this node group was successfully upgraded. Now we can start on the next one. So reduces risk of downtime, etc.
And what's just from a security perspective, and I'm assuming, Matt, there's a demo that we're gonna share with our snackers. As we're talking about this, because this is a huge thing that we hear a lot about. Where is the human in the loop in all of this when it comes to making those decisions? If there's actually true risk factor, how are you kind of making sure that the AI is not hallucinating? What's there?
So this gives back in a pre-flight all of the data that you have, and it's very contextual. So you're actually seeing the data that's being passed from step to step. But additionally, within the MCP server, you have to have an acknowledgement. So it's going to check back and say, do you want to do this? Yes or no? And of course, the service layer is going to evaluate that. So it's really hard for it to kind of make one call and hallucinate and just do it. It's got to go and make one tool call, bring it up to you, and then another tool call where it's actually going to execute the plan that it made.
So the MCP service actually provides a layer of security in this process as well. That's really cool. Okay.
And it's very deterministic on the back end as well.
Actually, can you expand a little bit on that deterministic portion on the back end, and then we'll dive into the architecture? I'm kind of interested on the answer for that one.
Yeah. So deterministic is the queries that it makes against AWS, the inputs for those particular API calls, those are all very fixed. So the way that it looks to make sure a cluster is ready, all of that stuff is static, whether I do it through a CLI or whether the AI is implementing it through MCP server. What you see is what you get. It's not going to throw in arguments and then just do something that was unexpected. If your arguments are right, your output's going to be right.
I thought that might be the answer, but I wanted to make sure that I was understanding it correctly. Can you, before we jump into the demo, can you do me a quick favor and kind of walk through what the architecture looks like so our snackers kind of get an understanding of just kind of high level what we're going to be looking at?
Sure thing. So I'm going to interface with it through Cursor. I have the MCP server loaded into Cursor. And so when I interface with the Cursor agent, it's going to use the MCP server. Those calls are going to use streaming HTTP protocol and actually talk to a containerized process that's running on my machine. That containerized process has the fast MCP layer. It has a CLI, and then those calls are all going to go into the Python service layer, and then go out to AWS API through Bot03, also Python process. AWS is going to come back with the result through the service layer, and then back MCP responses to the agent.
Okay, that makes sense to me. Kareem, you want to see it?
I do actually, and I'm surprised it made sense to me too. So.
Matt, before we jump into demos, is there anything else you'd like to share about your process or learnings, or do you just want to get into it?
Yeah, let's get into it. I think the most fun is kind of talking to the AI about what you're going to do with the cluster. So here we are. We are in Cursor. We've got Claude as our agent, and we are going to start using the MCP tool.
Mechanical keyboard stuff's awesome.
Yes.
Well, we did talk about that. He likes old tech.
So you can see it's running the list EKS clusters as part of my EKS upgrade MCP tool. We expand on this. You'll see that it got a response, or I was looking for US West 2, and it's got a cluster and the name of the cluster. And now it's running actually the upgrade available. So it's getting all the information from this, and then it's giving me a summary of that. So, it's upgradable. It's going to do a control plane and node groups. This is the version it's at. This is the version it's going to go to. It has 2 node groups. This is the AMI that it has, and it's going to move it to this new one. So this is an old one from September. There's one from January 15th. It says that there's proxy skew. So this is part of the pre-flight check that it's running. It's a warning because it's going to be 2 versions behind when it's there. So it wants to let you know that, yeah, it could work, but you need to upgrade this one in the future if you want to do another upgrade. And then we can say, do we want to execute the upgrade? Do we want to get a detailed plan? So I want to ask it to perform the pre-flight on that. I want to know exactly what it's going to do, what all the steps are, things like that.
I can see already how this saved us, just in watching this, an hour's worth of work.
So do you have a system problem defined somewhere or guardrails around in your cursor, Matt?
I do not. So these are coming right through this. In fact, now you can see it's running this MCP tool to get the upgrade plan.
Well, and I wonder if the guardrails are kind of built into the AWS agent too, probably.
No, it's actually built into my MCP tool. So I go through and I bring all of these data points up. And if the data points aren't there, or there are issues, it's actually going to pass I can't update, or I can't do that, and a failure state. That failure state has information that the agent will interpret for me and say, this is why you can't do it, things like that.
I understand.
This is what I really like here is the execution plan. So it talks about, how it's going to do the update. It says, we're going to go from 132 to 133. It's going to make a new launch template. It's going to update node group A, then it's going to check it. Then it's going to update node group B and check it. And then it's going to give you the whole thing. So now it's saying, it's ready to go. And then you're saying, okay, let's do the upgrade. So now it's actually running the MCP tool EKS upgrade, which is different from the one it ran before, which is with a plan.
While this is running, Matt, from a maintenance standpoint, are you finding that you have to make changes to the MCP server on a regular basis, or is it like you've got it working in a nice state and you haven't had to worry about it too much?
There are some changes I've had to make based on different types of images. So, for instance, naming conventions for images. There was a GPU enabled AMI, and now it's an NVIDIA AMI. So, the
Mm,
application needs to know what is that upgrade path when there are these sort of gaps. For some of them, where the AMI is just a new version of the same convention, that's pretty easy. It knows that there are upgrade paths from Amazon Linux 2 to Amazon Linux 2023. I built some of that in. But once you find that there are these upgrade paths, the good news is when you do the pre-flight, it'll say, hey, I can't do this. There's no upgrade
uh,
path.
okay.
And then I have to go and actually update the MCP tool or the Python behind the scenes to handle these different upgrade paths that don't exist. So that's the deterministic part of it. And that's kind of what keeps it a little bit safer. But I'm able to, conversationally, work with these particular tools.
Yeah, that's pretty neat.
So here is the cluster actually being upgraded after the MCP tool was called. You can see it's the DevNet stage cluster. The status is updating. Additionally, you'll see the Kubernetes version, the upgrade insights. This is the same information it gave us in the pre-flight, and then the health and everything overall. Let's see here. Yeah, and these guys aren't going to upgrade until this guy is done upgrading. So it still doesn't solve the amount of time that it takes AWS to do the work. It just makes it a little bit easier to go do something else while your AI is handling it.
But that's just not on you anyway.
Correct.
That's the service they provide. So
Exactly.
it's a true agentic tooling brought into your SRE and DevOps kind of work. So it's a great way for our stackers to see that. I also saw recently another MCP server for just plain Kubernetes out there managing clusters as well. So you can see the power in bringing in AI within the infrastructure itself, Matt.
Yeah. But one of the things I thought was interesting is if you look at like Kubernetes API MCP servers, these things can all work collaboratively. So
Right.
if you're doing an upgrade and it wants to check and say, okay, what's the status of my cluster afterwards, then it will go and make those API calls and it can follow on both processes in real time. And I think that's, being able to have those insights is super helpful. When I was talking about AWS CLI, it's essentially just running the AWS CLI. It knows all the arguments to it. As long as I have an authenticated session, it takes care of what it needs to do. That's really, really handy because if there's something I'm checking about, like tell me, is there something going on with the cluster? Is there, something else that I need to do? Let's see if I can actually show some of that real fast. Okay, so let's say I want to check on the cluster while it's working and I want AI to do that for me because AWS is doing some processing. I could ask and it will actually know that I have AWS CLI and it can do that.
I mean, you're technically burning down the forest by having AI do that when you can just look at
Yeah, but he doesn't have to leave his IDE.
Yeah, I just work here and I can code and change and then I can minimize this and work on something else too. Yeah, so here you can see it's confirming with me. It wants to know what's going on with the different clusters. And this is not using the tool. It's going to go and try something else. There it goes. See? So it knows that I have a cluster there. It's going to get more information about it, the node groups. So it can say that it upgraded to 133 and that it's starting to work on the node groups here. And this is actually the AI doing quite a bit of work for me. So it's saying, give me the update. Are there any errors? What it's doing in the process, things that if I had to do this, I would have to look up the syntax for these commands. I would have to go and be able to see the whole chain of events. And here it's able to go run the command, get the piece of information that it wants, and then it's going to provide a summary at the end. Not necessarily related to the MCP tool, but if I want an agentic way of knowing exactly what's going on, this is how I can tell. So I can see that there are new launch templates now in place, and I can see that it's going to be changing these out. It's draining them, etc. So there are already instances here that have new launch templates being brought online.
This is great. I mean, it's a perfect example how AI can simplify your workflow. Here, you can even up-level this by making this fully that workflow fully built in something like N8N, where you introduce like a form for your team to say, here are the nodes that I want to upgrade, submit, and then the workflow gets executed based on that form, and then you get the system logs that output it into a Splunk instance, for instance, and then you just sit there and get notification when it's done. So you can just walk away from even the CLI or even your IDE, which is pretty powerful.
Coffee consumption went up through the roof after he built this. Matt, unfortunately, I mean, I'm wrapped. I'm sure our snackers are wrapped, but unfortunately, we're running out of time, and I don't think we can fully wait for the cluster to get deployed. But because you're a new guest, we always have to do this. We have to ask you what superpower you would choose to have and why.
That one's probably an easy one. I think I'd choose a superpower like the Flash because, I need to get a lot of things done. I have so many hobbies. I have so many things I'd like to do in life. And if I could just accelerate and be able to get more done in the same amount of time, that is the superpower I would like.
Oh, that sounds good. We don't get a lot of flashes like that, but I get it. Well, snackers, I hope you enjoyed Matt's demo of upgrading an EKS cluster using some AI tooling and some MCP servers he built. I hope this inspires you to start to leverage these kinds of tools in your own infrastructure, obviously with some security and guardrails in mind. Matt, thank you so much for the demo. It was crazy interesting. And we'll see you guys next time.
Thanks, Matt. Thank you, snackers.